This is the second part to our dividing polynomials series. This video is going to focus on long division for dividing polynomials. If you watched part 1, remember we used the greatest common factor, or the GCF, to divide our polynomials down into a more simpler form. Sometimes we even used a diamond method to make sure that we factored a trinomial so that we could then simplify it down. Here we're going to be dealing with problems where we can't use those methods, so long division is going to have to be the method of choice. So dust off those long division skills and let's get to it. Our first example for the long division process is going to be very similar to the last example from part 1 because it's the exact same problem. The only difference is, instead of factoring out our perfect trinomial, sorry, it's not a perfect trinomial, but factoring out our trinomial, we're going to just do the long division method and divide it by x plus 3. So, remember, this is the term that goes underneath the radical. This is the term that goes outside of it because that's what we're dividing by. So it's very important to first set up the problem correctly. We get x plus 3 on the outside, x squared plus 8x plus 15 on the inside, and I will erase what we have up here, and now we can get started. What's going to happen here is we are trying to divide this term, x squared, by this term. So if I want those to be able to be canceled out, I need to think about what can I multiply this x by to make it the same or as close to this as I can. And I know that x times x gives me x squared, so I'm going to put an x up top, and this is where our answer is going to go. It's going to go all the way up here. And now I multiply this x that we came up with by the outside term. And what does that give us? That gives us x squared. X times x is x squared plus 3x. And now, just like in normal long division, we subtract. So what's going to happen here? I have x squared minus x squared, so this becomes 0, plus, and I have, remember, even though that there is a plus here, I'm really subtracting this entire quantity. So I subtract them, and this is really minus 3x. So I'm subtracting both of those. That is one of the key things you're going to have to make sure that you are comfortable with. We're subtracting them. And now what is 8x minus 3x? It is 5x. Okay? And then just like regular long division, now we bring down our next term, so plus 15. And we do the same idea. It's rinse and repeat. I have 5x, and I want to make this x as close to it or the exact same if I can. Well, what can I multiply x by to make it 5x? Well, that's a positive 5. So plus 5 goes up top. And now we multiply the 5 by all of this. So we're going to have, excuse me, we're going to have 5x. 5 times x is 5x. 5 times 3 is 15. And remember, we are subtracting that quantity. So I'm going to distribute the negative sign again. So this is a negative 5x here. This is a negative 15. And now I can just combine them. 5x minus 5x is 0. 15 minus 15 is 0. And we get our answer, which we should have known if we watched the last video. It is x plus 5. That is what we get when we divide x squared plus 8x plus 15 divided by x plus 3, and we used long division. Now that we've gotten the first example out of the way, started to see how some of this works, let's try another one that might be a little more complicated. Alright, for our second example here, we have 4x squared minus 2x minus 12, and that quantity multiplied by the quantity 2x minus 4 being raised to the negative first power. And we saw this in our part 1 video on this division of polynomials, but in case we haven't watched it, remember that -1 power means that we put it underneath as if it's a fraction. So I can move this. Underneath. That gets rid of our -1 power, and we see it as a fraction here. And hopefully we're getting to the point where we realize, oh, if I have a fraction, I'm doing some division. So we're going to divide this by this. So let's set up our long division. On the outside, we will have 2x minus 4. Draw our division radical, and then 4x squared minus 2x minus 12. Alright, and then, so we have some room. Let's get rid of the original problem. And now we can start doing our division. Just like last time, we take our first term here, 4x squared, and we want to divide it by 2x. Well, what do I have to do to 2x to make it 4x squared, or as close to it as possible? And the correct answer to that is multiply it by 2x. So we then take our 2x up top, multiply it by the entire divisor, and what do we have? We have 4x squared minus 8x. And now remember, we're subtracting this from the top, so I'm going to distribute that negative sign so that this becomes a negative 4x plus 8x, and now I can just add them together like normal. So what does that give me? If I have 4x squared plus a negative 4x squared, I'm going to have 0. And if I have negative 2x plus 8x, well, that's going to give me a positive 6x. And now I can bring down the minus 12. Now I'm working with this term. I'm working with 6x minus 12. I'm still dividing it by 2x minus 4. And I need to figure out what can I do to my 2x to turn it into a 6x. And well, 2 times 3 gives me 6, so I'm going to multiply it by 3. And it's a positive 3, so we put plus 3 up top. So 3 times 2x is 6x. 3 times negative 4 is negative 12. And just like before, remember, we're subtracting this quantity, so we got to change our signs. This becomes a negative 6x. This becomes a positive 12. And now we can add them together. So what do we have? 6x minus 6x gives me 0. Negative 12 plus 12 gives me 0 as well. So our final answer becomes just the quantity 2x plus 3. The stuff that we put on top. Alright, so sometimes these will work out nicely like the first two examples have, and we're going to get a single answer like this. But if you remember back to your long division days, sometimes we had radicals. Or sorry, not radicals, sometimes we had remainders. And we learned how to do decimals with our long division, so we got rid of those remainders. But here we don't really have that option. So our next example is going to show us how to handle division with polynomials when it does not divide out evenly and we end up with a remainder. Alright, for our final example here, I've promised you a problem that's going to have a remainder, and by golly, I'm going to make sure I deliver on that promise. So we have 6x squared minus 3x plus 9, and we're dividing it by 3x plus 2. Now, we don't really have any indicators here that it's going to have a remainder right from the very start, so we can't just look at it and know that. So we have to go about it and start it the normal way. I've got a 6x squared here, and I have a 3x, so I need to figure out what can I do to 3x to make it into or as close to 6x squared as possible. Well, 2 times 3 gives me 6, x times x gives me x squared, so I'm going to multiply this by 2x to start off with. And what do we get? We're going to have 6x squared, which is what we want, plus 4x. And since we're subtracting, just like we've done in all the others, I have to change my signs. So this is going to become a negative 6x, and this is going to become a minus 4x. And then we basically add them together. So 6x squared minus or plus negative 6x squared gets me 0. Negative 3x plus a negative 4x gives me negative 7x. And then I bring down my next term. So I have negative 7x plus 9, and I need to use 3x plus 2. Sorry, I have negative 7x, and I need to use my 3x to get close to it or equal to it. And now we might be noticing, oh, I'm probably going to have a remainder here, because 7, or negative 7, is not a multiple of 3. So I can't go into it evenly this time, but we're going to need to get as close as possible. So what multiple of 3 gets me close to negative 7? And that answer is negative 2. So I'm going to multiply by negative 2. That's going to give me negative 6x minus 4. Since we subtract in our division, remember, we're going to flip the signs on both of them. So this becomes a positive 6x and a plus 4. That way, now we just add them together. Negative 7x plus 6x is negative x. 9 plus 4 is 13, so I have negative x plus 13. And we've run into something we haven't seen before. First of all, after this step, the x term had always gone away. It's still here. This was usually also gone away with. It's still here. And I don't have anything else to bring down. We have a remainder. So how is this going to look? In previous examples, what's up top here was our quotient. So it was just 2x minus 2 was our answer. But now we have this remainder. So the way this works is, since it's minus, we'll have minus x plus 13 all over 3x plus 2. And hopefully you see that, oh, I got that 3x plus 2 on the bottom because that is what we divided by. And that's how our remainders are going to work. You take what's on top from the division, put it in front, and then behind it we put the remainder over what we were dividing by. And that is dividing polynomials with long division. Now the next video, which I guess could be part 3, but it's going to have a different name, shows how to kind of do this with a shortcut. So hopefully that makes sense to you, and if you are interested, please join me in the next video.